Dear students, welcome and thank you for tuning in to this video. I'm Dr. Loya Al-Zobi, and in this video we are going to continue our discussion about the medical instrumentation class, specifically about the measurements of respiratory system. And in this video I will be talking about ventilators and respirators. In the previous video I talked about the respiratory therapy as well as about the design and use of inhalators. Now we would like to go to discuss another instrument that is used in respiratory therapy, which is ventilators, and sometimes people are called respirators. So these two names are used interchangeably. The term ventilator and respirator are used interchangeably, just as I mentioned before, to describe equipment that may be employed continuously or intermittently to improve ventilation of the lungs and to supply humidity or aerosol medications to the pulmonary tree. This is different from the inhalators because inhalators are used with people who can actually spontaneously breathe on their own, but they need extra oxygen or they need to have some medications. Now, ventilators and respirators, on the other hand, they are very important for people who actually cannot do the respiration on their own. Let's look at a definition of a medical ventilator. So it is an automatic machine designed to mechanically move breathable air into and out of the lungs, and that's a very important thing to consider mechanically in order to provide the mechanism of breathing for a patient who is physically unable to breathe. This is a big distinction from inhalators, where the patient is expected to be breathing on his or her own, or is breathing insufficiently. So that's very important distinction. This is a very important distinction between ventilators and inhalators. The other things that, what do we mean by mechanical ventilator as a device, as an instrument, as equipment? You remember we are in the medical instrumentation class and we would like to look at these instruments. So a mechanical ventilator is a complex system consisting of a power supply, that's the first component. Then we have compressed air or oxygen or medication, that's the second component. Then we have a drive mechanism to provide motive force to push air in or out, or oxygen in and out the patient's lung. And also we need to have a control mechanism to manage the gas flow, volume, pressure, and timing. And those four entities are very important. We're going to talk about them today, and I'm going to explain them because there is a misunderstanding about how they are used as control mechanisms. So keep in mind timing, pressure, volume, flow. We're going to talk about the control and cycles, and I'm going to explain them in this video. This mechanical ventilator is connected to the patient lungs through breathing hoses and special tube inserted into the patient airway. I would like to draw your attention to flow, control, pressure, and timing. We will spend some time understanding what are those control mechanisms and how we're going to use them in designing an instrument or a ventilator or a respirator. So that's something important. So let's talk about classification before talking about control. So ventilators can be classified by the variables that are controlled in this instrument. We are going to be talking about pressure, volume, and as well as the those that start, variables that start or trigger the instrument, or the variables that sustain the quantities that flow or volume or pressure, as well as the variables that end inspiration or expiration. We would like to look at this. So cycle is important. When we say cycle, it is the thing that's going to end the inspiratory mode. So the cycle is the thing that's going to stop pushing air into the lungs and allow the patient to do expiration, right? So that's very important, and we're going to talk about it a little bit more. So all these variables, so we can classify the ventilators based on these variables in order to maintain also maintain the expiratory support or baseline pressure. And remember that when we are trying to, if this is a time and this is a pressure, if we are trying to add, gas into the lungs, we're not going to start from zero. We should have to have to maintain a baseline pressure here at the end of the expiratory cycle. And if you recall from the previous videos, we talked about the volumes and capacities of the lung. And we should remember now that the lungs, the volume inside or the pressure inside the lungs does not go back to zero. right? Or the volume of air doesn't go to zero. So all what we need to take from this statement here is that ventilators, we have a lot of different types of ventilators, and these ventilators can be classified based on different variables. They, control, trigger, or sustain, or cycle. Cycle means, again, end, inspiration, or the expiratory support. And we're going to talk more about them as we move on in this video. So the main ventilator categories are, so if you would like just to summarize them, you will have power input, power transmission or conversion, and I'm going to show you a schematic with some examples. And then the most important ones for us actually is the control scheme, right? And the output or waveforms. So I'm going to talk more about it. So in control scheme, remember we have two control modes. We have volume control and pressure control. And in a pressure control, for example, you increase the pressure to a specific value for a set time, and then you let the pressure go down to allow for exhalation. And we're going to explain it a little bit more. And the output, I'm going to talk about also the waveforms. But before we go into the classifications and understanding how do we control a ventilator, or how do we control, respiration through a ventilator, I would like to show you this schematic actually.